Alright, we should be live now. We'll wait for people to come in. Wait for y'all to hop in the chat. Let's go. Let's back this stuff from last night. I use my iPad a lot more. I'm an Apple guy, so I got a iPhone, iPad, and MacBook. And use the Mac for streams. And sometimes if I want to break down weather, it's a bigger screen, which is nice to have. But typically I use my iPad mostly throughout the day. We get the 0Z GFS coming out too, so we'll take a look at that in terms of we'll take a look at Fiona and also the system down the line, which I think as we progress throughout this, and as we once we get our first National Hurricane Center cone with this system, which we'll probably get some point over the next couple of days, and then throughout the week, this weekend, once we get that first National Hurricane Center cone, that starts to show a system going into the Gulf, which I think we could be looking at some point. I think that's when these streams will probably get popping, because more people come in as it gets more popular. Western, no, not a chance. Western Mass is not better. Eastern Mass all day, baby. I mean, I'm technically Central, so I'm like on the border of Central and Eastern Mass. But since I'm in Worcester County, consider myself Central Mass. But yeah, so let's hop into it. Let's take a look at satellite here. Let's take a look, baby. Let's go in. Mm-hmm. Let's take a deep. It's beautiful satellite presentation. Probably still waiting for the winds to catch up. Okay, I tweeted earlier, definitely. I shouldn't have used definitely. I hadn't looked at recon yet. But after looking at recon, I can understand why National Hurricane Center. I don't blame them. You have to have physical evidence. You can't just go off a satellite presentation of why you think it should be 130. I think they did a little bit, probably in their 8 p.m. and their 5 p.m. with the 120 and the 125 upgrades, those ones that they did. But I think now that the National Hurricane Center, a little bit, multiple passes of recon going through the center, and max winds, only support of really more than 125 miles per hour. It makes sense. It makes sense why the National Hurricane Center kept it there, and can't blame them. I was just, I saw that satellite, and I didn't even check the recon yet. I saw that satellite, and I was like, whoa, this thing is really taking off with as much as the eye has warmed now. So we're down to around 947 millibars currently. See if recon has even gone in there. And for y'all here, we are gonna go into the next system. But I just want to go over the basis for Fiona, because I do have some Nova Scotia followers as well that have some significant interest in this storm. And even I'm going to go over, actually, there's going to be some U.S. indirect impacts with Fiona as well that I tweeted about earlier today. Believe it or not, some places are going to get impacted from Fiona. Probably more in my area, probably not relative to a lot of you, but still. Looks like they finished their mission. Recon finished their mission here. But new recon plane going in through, looks like it's just passed in between Puerto Rico and Hispaniola at the moment, Dominican Republic to the east. So it'll probably be in there within the next hour. We'll see it. We'll see it get in there pretty soon. Again, if you guys have questions, I'll try to answer them at some point. Yeah, it is a good thing that this didn't hit the U.S. it directly, or at least it's not going to. Knock on wood, 99% chance. Always gotta leave that 1%, for the Mother Nature's binge drinking night or something. I don't know, something crazy that Mother Nature has in store. But it's a good thing. This thing could shift west. If I take a look at if we show the National Hurricane Center cone, you can see, we had Gaston form, Gaston, 50-mile-per-hour tropical storm. You can make a case it's a little bit stronger, but based on satellite presentation, but it is out there meandering. Unless you're flying JetBlue, it's probably not a concern. I hear JetBlue is really interested in flying through tropical systems these days. Yeah, I'm just saying. So if you really want to go see one of these, just hop on a JetBlue flight and they'll take you there. But yeah, we got 947, 125 mile per hour, as I mentioned, with Fiona. I know I'm going over a lot of the simple stuff. Probably a lot of you are looking for, more of the in-depth analysis potentially, or maybe you're not. But I like to lay the groundwork first. Lay the groundwork, and then we get it, and then we're gonna deep dive. I promise y'all. We're gonna deep dive. You just wait it out. But I gotta establish the groundwork first, and then we can really hop into the analysis. But if I show you the cone, I don't even need to go into there. If I show you the cone, this could slide as far west. The center could go right through Halifax almost, which is in central, the south coast, near the south coast. I don't know I forget if it's directly on the coast or not, but near the south coast of Nova Scotia is where the center is where as far west we can see the center potentially go. And again, this is 1 through 3, and 3 to 5 days is subject to much more variability in the forecast change. So, when I say indirect impacts that we could look at with this storm, well, the direct impacts are going to be probably here. And honestly, eastern Maine, this eastern part of Maine right here, I'll draw it out for you. This eastern part of Maine right here, this clip, could honestly see if we saw a track that went like right here, the center, could honestly see some direct impacts from this system. We could have to worry about some 50, 60 mile per hour gusts if it were to be on the western side of this cone. And even Cape Cod would have to potentially worry about some 45, 60 mile per hour gusts if we see a track on the western side of the cone. Just because Cape Cod will be a little bit more indirect. And what I mean by that is if I show you on the models, we're looking at a pressure, and I'll go back here. We're looking at a bit of a pressure gradient. So if I want it, 10 meter. Yep, bingo. If I show you, you can see Fiona. This is Fiona right here. I'm sure you all picked up on that. That's Fiona right there. Our big bad hurricane. Which seems like the GFS is initializing a little bit low. Yeah, it is. It is definitely. It's about, it's almost 10 millibars too low with it. That's a lot. It's about 10 millibars too weak. So that's something to consider. It's not a hurricane model. It's a global model, so it's not a hurricane specific model. So it's not expected to. It's just to get the general idea of the track in general. So when you're like 18 hours away and you're looking for the perfect track from a global model, it applies to winter storms and hurricanes as well, that you're probably not going to get the most perfect. You're probably not going to get the most perfect forecast, and that's not what we use it for. It's the GFS. We don't use to make a forecast. We use the GFS and we use the Euro and the CMC. We don't want to use the CMC, but it's a tool. They're all tools. That's what the models are designed with. It's for people who know something about the weather to use as tools, and then make a forecast as they want to. It's up to them depending on how much knowledge they have, or just experience. Those two can go hand in hand together, but that's what we use these models for. So it's not going to. we're not looking for the exact perfect track, but just in general, if I play this out, you can notice, look what we have here to our west. We have our big dome of high pressure. It's not ridiculously strong. It's not like a 1040. We don't have a 1040 ridge right here, but it is a present high pressure. I guess that's the word I'm looking for. Very present. So what happens is the contours between the high pressure and the low pressure, which is still a little bit down here, but you can see the contour that's created in between. And this is just even regular winds. In between here is where these lines, imagine they're pushing together. Imagine this is not how it works in the atmosphere, but imagine, in between those magnets, in between the magnets that are getting closer, and the closer they get, the stronger the magnetism is in it. That's not how this works exactly in terms of the atmosphere. Just imagine that process. So in between there, in the middle especially, is where we can see that contour between the high pressure and low pressure, and that can create some gusty winds. I'm sure a lot of you have you guys noticed, maybe potentially after you see a winter storm, that when you see a winter storm, after it roams through, maybe it was a windy one, or maybe it was like intensifying and it was kind of weak when it moved through you, but then it was strong as it moved past you. You notice that the next day it can tend to be sunny and windy. I don't know if any of you noticed that before, but a lot of times I have. The day after, it's sunny and windy, cold too. The reason is that it's that pressure gradient between the high pressure typically that you had and the low pressure. And that contour gradient is able to create gusty winds, even though there's no, weather falling. There's no weather falling, but there's no rain droplets or there's no snow falling out of the sky. That contour that the high pressure and the low pressure create is able to get gusty winds. So that's what we're looking at in terms of indirect impacts. And that's also, those gusty winds are going to also help drive some probably, 10 to 15 foot waves just offshore of New England. So that's what we're definitely, that's the main concern definitely with this one for southern New England. So, and even along the East Coast, you probably don't want to go on. I don't know anybody that will be, but if you are happen to try and go on a beach this week or this weekend, probably not the best idea given the rip current situation. But as the storm, you can see as it approaches, and part of this why this has been increasing too, probably not talked about a lot, but the threat has been increasing, is because GFS has been correcting this trough, the timing in this trough. So it's pulling in. I'll show you. I'll go to upper level in a second, but it's pulling the storm in a little bit closer. The trough is slowing down a little bit more, so it's not as fast, and it's not pushing Fiona as quickly out to sea. The trough's a little bit stronger. It's pulling Fiona in a little bit more. So with a weaker trough, Fiona's just able to go where it wants to, with that weakness in the ridges. But imagine we have our high pressure here. Lordy. We'll go high pressure. We'll go high pressure. So the reason why models have been correcting on this over the past couple of days or so is 500 is GFS has been correcting the past couple of days on pulling Fiona in a little bit closer. And that's why, because when people see out to sea, they just go, oh, well, it's just out to sea. I'm done looking at, the models. Let me just look at the satellite and the recon and all that stuff and just, look at the satellite images. But, there still are going to be impacts. Nova Scotia is going to get probably one of their worst hits in history. Like, this is going to be historic. Probably not going to be talked about because U.S. national media doesn't really care about anything that doesn't happen outside. If it's important enough, they'll talk about it. So this will probably be important enough after. But before, it will probably get barely mentioned. Most people won't even know about it unless they're told about it by someone like me. That's the reality. So I'm going to keep following this one. But also, there are going to be impacts for the New England area. Indirect, not direct, but still indirect impacts. And what's been happening is, I'll show you. Notice how much broader this trough is. Look at this. Very, very positive at this point in terms of the depth in the trough. And look how broad our trough is. So basically, Fiona is not going to feel much influence, and you can see, these contour lines. It's just going to slide right off here until this ridge, until the depth of this. Sorry, not ridge. Until the depth in this trough pulls down a little bit more, and we see something more like this. And it's probably not negative. I don't think it ever even went negative on some of these runs, and then it's able to pull in, and then it does something like this. But now we've been seeing more runs with Fiona. Watch the correction that other models and even the GFS has made. Notice the axis. See a little bit going back and forth, but then we can see. Look at our trough now. Still positive, very positive, but look at the depth in the trough now. That's now, and then look at previous. We'll overlay it in yellow. Oh, nope. Will this be too hard to see? It shouldn't be. Oh, here we go. And then that's the previous. You see the difference? That's a big part of why we've been seeing these changes in terms of, central Nova Scotia, western Nova Scotia being much more at risk for this storm. So the stronger the trough, the more influence it's going to have on Fiona, and a stronger trough is also going to slow down. So it's going to be able to pull Fiona in and pinwheel it in a bit. It would feel sooner in terms of latitude, even though it's not that much sooner. And notice the difference in location. Pulling it all the way back. Pulling Fiona all the way back from here. And now we look at this slowly each run. Just pulling it closer, closer, closer every single run. And that's a solid item. That's a good 200 plus miles right there, 200-300 miles difference over the past day or two or so. That's a big shift. That's why we say nothing's ever set in stone. So people get so I'm not, obviously it's not going to hit the U.S. directly. So that's not what I'm trying to say. Oh well, you looked away from it and now it's going to be a direct impact. That's not what I'm saying. I'm saying is we just saw a 200-300 mile shift because of the same stuff that I talked about on stream for days. Was the depth of the trough and how strong it is, which are directly correlated. And that would lead to a system that could slow down at the trough, that would slow down, and that would be able to pinwheel it a lot closer to us. And that's what we've seen. And that's why the indirect impacts are going up in our region. So if I play this, and this is going to connecting all the dots right here. And that's why I said we have our high pressure here, and then we have our really, really strong low pressure here. And this contour in between is what's going to create gusty winds, and probably, potentially, we could be looking at 30-40 mile per hour gusts throughout the day, Friday through Friday evening, potentially. I mean, what's the time we got here? Yeah, that seems about the timing. Zoom in a little bit more. Oh, this is in knots too, so that was in knots. If we play it here, you see Fiona's over here, and this is now miles. Or no, it's still knots. Sorry, it's still knots. But it's just the scale is different. The scale. This is the scale of numbers. That's all that's different. The color scale for numbers, and these are sustained winds too. These are not gusts. Sustained winds potentially Nantucket. Nantucket It could be in for some real interesting weather. They usually get in on those fringe storms. This will probably be. It's not going to be technically a fringe. If it gets close enough, it could be. But that is the most. That is not the. I won't say the most, but that is why this has gotten a little bit more interesting with Fiona. This contour between the high pressure and the low pressure, this gradient, we're going to see some pretty gusty winds. And if this continues to overcorrect, usually this is the kind of range where we would see models go back a little bit and then they would overcorrect a little bit more. And, it wouldn't be too different from now, this 3-day range. That's what we see a lot in winter storms where models go, all the way, make this big change and then they go back a little bit. And then, they get back to where they were a few days out. So it wouldn't shock me if this was as far west as it came. But if it's not done overcorrecting and it's really messed up, the depth of the trough and the strength and the timing, then absolutely we could, I talked about a little bit earlier, that some direct impacts for this part of Maine could very well then increase, and even we could be talking about some rainfall here and potentially some 50-60 plus mile per hour wind gusts if it were to be able to get close enough. If we saw a track into central Nova Scotia or something, then that would increase the threat for here too. Regardless, you can see the whole northeast is going to be pretty gusty. These are just sustained winds, so they're probably going to be sustained winds. Sustained winds probably 10-20 miles per hour. This isn't even peak time. Yeah, you can see 10. It looks like a lot of U.S. will be somewhat windy. You can see the contour on this side. This is a little bit more terrain induced over here. But you can see what I'm talking about. And I promised y'all we are going to dive in to 98L. We will dive into 98L. It's just there's a lot of interesting stuff here. And if we'll go take a look at Nova Scotia impacts, and then we'll look at recon quickly, see if anything. Look at satellite quickly at Fiona. So this won't take too long. So in a few minutes we're gonna take it. We're gonna look at 98L. We're gonna deep dive again. I'm gonna go over a lot of stuff that if you weren't here last night, I will go over again and explain to you why the ceiling is so high with that system. So yeah, we'll go back North Atlantic. And Nova Scotia is in for a really significant system here. Really, I mean, just major impacts. So as the storm is going to make its extratropical transition, so it's going to go from a warm core to still hold some warm core characteristics. Still going to bring up that really that significant moisture feed. It's going to bring that up, but it's also going to have some cold core characteristics as well of a mid-latitude cyclone at around the time of impact in Nova Scotia. And this is what's going to make it a truly beast. So sustained winds are going to go down, but wind gusts are going to stay really strong. And depending on the forward speed, it's not going to be moving super fast, which will be good and bad. Good, because a lot of times you can see this kind of storm just race up, and that increases your wind gusts. The bad news is it's probably going to increase your flooding threat. And also the wind threat will stay for longer. So that's the bad news. Again, if you haven't, anybody that lives in Nova Scotia, really any part of Nova Scotia, the western fringes probably won't be too bad. At least it looks for now, not super bad. It will be pretty manageable. But anywhere, from Halifax east, Halifax is the most populated. They talk about Halifax the most, I know. Highly populated area. Anywhere east of that, Cape Breton, Sydney. Sydney is a pretty highly populated area. If you know anybody there, you should give them a heads up. I'm sure they're talking about it in their local, but when people text you something that maybe you're not that close with them. If someone you don't know texts you something, about a storm, usually if they know about that, that means it's probably pretty important. So, and if you get multiple people to do that, that maybe you're not even that super close with, or that's not like you're not like weather fanatics. If someone lets you know about that, they're going to probably take it a little bit more seriously. So it does. If you do know anybody, you can give them a heads up. Just check in. Maybe you don't have any friends in Nova Scotia. It's not the most highly populated area in Canada, so wouldn't blame you. But when we see storms transition to that extratropical phase, we start to look at the rain start to shift from the north side to the west side. Typically like you'd see in your nor'easter, the flow starts to get backed, and the strongest moisture gets pumped into the northwest side. So it pulls in. Oh no. So it pulls in this moisture here, right? This is what we see. Pulls this moisture all the way down, and it starts to back the flow, and the moisture gets pushed this way. Obviously not this far, but just the direction I'm trying to point in to show you. The moisture gets pushed that way, and then we see some, deformation bands set up, or etc. So we saw that in Irene, we saw that in Isaias. We see that a lot of the storms that increase in latitude and come up to, the northeast. In this case, Nova Scotia, the flow starts to get backed, and then we push moisture north and west of the center of the system. And so that's why typically the eastern side, it's typically pretty dry. You'll see squally conditions, probably some thunderstorms, maybe even a tornado threat, possibly. But when we see these systems start to make the extratropical transition, that's when we see the rain start to get pushed to the west in the north of the system rather than the east. That's a good tell for a warm core versus a cold core system. Is cold core, you'll see more of that precip. The flow gets back and gets pushed to the west and the north. But with a warm core, you see the heaviest of that precipitation is on the eastern half of the storm, in the northern and the eastern half. The northeast quadrant. We look at for the eye wall. And it's not just the eye wall in terms of where the most significant area of precipitation is. But that eastern half of the storm with warm cores where you look for the most rainfall, whereas a storm that's moving up in latitude and starts to transition to a mid-latitude cyclone, but still has some of those warm core characteristics, and then that's when we see the rainfall. We look at this area instead for the heaviest rainfall. That's the area that we look at. So heavy rain for sure. There'll probably be some flooding. It's a little early to get into how specific those rainfall totals is, because the day before, even with Puerto Rico, it was 8 to 10 inches was the maximum, and I think like 10 to 15 a really isolated spot in their maps, and we ended up seeing some isolated 24 to 36 inch totals. A wide spread throughout the island of 10 to 20 inches, which was not the forecast, just a day out. So we're going to have to get a little bit closer with this one to figure out rain totals and where that happens, because track is really important for rainfall totals. So it's too early to figure out flooding. But wind-wise, wind stays all around the system. And obviously rain, it's a little bit easier to bring that down. So typically the west side probably won't be quite as significant wind-wise, because it's still got some of those warm core characteristics, remember? So I would look for the north side, where that's just going to bring it down. Those radar echoes are going to help to bring down, because it is a little bit more of a mid-latitude cyclone at this point, remember? And it's going to bring those winds down that are potentially in the mid-levels, or the lower levels, not the mid-levels quite, but in relation just higher up. It's going to bring those winds that are a little bit stronger higher up. It's going to bring those wind gusts down. It's going to mix those down. So I would look for, just north of where the center of this system tracks, I would look for the heaviest wind totals, or I guess the strongest wind gusts, to be in that location. That's where I would look for. We saw one last year. And was it the year before that too? I think Newfoundland saw one last year. Someone can check me on that. I think Teddy in 2020 impacted, but I think we had one last year. I forget the name of it. I think that one impacted Newfoundland as well. And I think Teddy might have impacted Nova Scotia actually. I forget, but I mean, recently they've had one a year for the last 3 years. Um, it's not super. It doesn't happen super often, but Atlantic Canada does get hit. Probably it's a little bit different. No, I mean typically, think about in the Northeast region. In the Northeast region, typically storms at this point are now a little bit more extratropical because sea surface temperatures just can't support it, and more troughing in this latitude of the country. So at that point, it's probably going to meet up with a trough at some point. Once it starts to get into the subtropical region and anywhere north. So that's why it's pretty hard to see a fully warm core system move into this latitude. It's amazing how far it's actually going to go because the sea surface temperatures are really warm. I mean, I can show you those current sea surface temperatures, and even the last few years. That's why we've seen such the frequency go up in terms of the intensity as well in some of these extratropical warm core combo systems. But we take a look at the sea surface temperature. Ooh, that is super zoomed in. I don't know why. Here we go. But I guess it's not bad actually. You can see the Gulf Stream here, and there's little significant patches right here. And this is where I think this was Earl. And you can see those cool patches there. So when hurricanes move out, I'm sure some of you know this already, but when hurricanes move out, they use that fuel, and it doesn't just replace itself. It can a little bit if the ocean heat content is super strong. It will be a little bit harder than deep ocean heat content is. How deep do those warm isotherms go down the ocean? So if this is the surface of the ocean right here, it's a little diagonal. Sorry, but it's 30. Typically we look at that 26-degree isotherm as the bar for hurricanes, and it's 30 at the surface. But my 26-degree isotherm is all the way down here. That means it has all of this, to use up basically, and to support a hurricane to be able to track over there and use that fuel and be able to pump moisture in the system basically. Because remember, these are rotating thunderstorms at the surface that are pulling in moisture from the surface. That's how hurricanes work. So the more heat and the higher the ocean heat content values, the more it's going to be able to pump in that moisture, and we can see rapid intensification happen a little bit more easier. So this is when the whole Atlantic has strong sea surface temperatures like this. When I say strong, higher, above normal, even in the Gulf, 1 to 2 degrees above average, and these are with the updated averages to 2020. That is an environment that is prime. That's one part of an environment that is prime to see a hurricane that could strengthen significantly. And that leads me to 98L. 98L, the next system that we're going to have to watch. I'm sure a lot of you are seeing the GFS come out, so I'm seeing some Twitter notifications already. So I'm sure it laid down another major hurricane probably in the run in the Gulf, but where we can lay the groundwork down for this right now. This is where we're looking at. We're looking at the Caribbean. Storm was probably, I think it's around here somewhere. And we're going to be seeing this probably hold this latitude, and then we're probably going to see this gain latitude later in the week, in the weekend. Probably see it gain latitude some, because we're expecting it to strengthen. I think formation probably will happen at some point in the next 2 days. If I had to put a guess, I would say 2 days. There is some wind shear. There is some wind shear currently, but I think within the next couple of days we'll see this thing form. One second. There we go. All right. So now what we have to look at is obviously we have our warm sea surface temperatures. We have our warm sea surface temperatures. These are plenty warm. I can even show you on tidbits. I said I was going to look at recon, but I'm sure nothing crazy's happened. Boom, boom, boom. Zoom in. And these are, that's going to do it. 29, 30 degree sea surface temperatures with probably some pretty significant deep ocean heat content as well. Probably some significant deep ocean heat content. Does it give me that? Does not. I'll show you a map. Remember, I was just talking about deep. Some of you may have just joined the screen, but deep ocean heat content is how warm are those sea surface temperatures, below the surface, and that can help fuel a hurricane for more sustainable sea surface temperatures. Because when hurricanes move over, they leave cool spots. And they're less susceptible, to let that cooler water below the surface churn into the system, and then once that gets up into the system, it makes it harder for the storm to intensify, especially if it's a slow moving system. Especially if it is a slow moving system, and am I not going to seriously? I could have used a sec to come up. Didn't need climate change, but the values are strong. I can assure you, it's the Caribbean. It's the Caribbean with 30 degree sea surface temperatures in September. These have been fueling. I can almost promise you that the deep ocean heat content values are significant. Actually, let me try one more resource. This may have it. Are you serious? Yeah, that's fine. All right. So we have very warm sea surface temperatures. That's pretty simple. We have very warm sea surface temperatures, but we also wind shear. This is the next. Actually, we'll go over moisture first. This is what is the biggest part of the system. With what I was talking about with Fiona, you can see that dry air wrapping into the system, but it's still dropping in intensity, or it's dropping millibars. It being that strong, that's what I talked about in terms of, still having some warm core characteristics, but also that transition to an extratropical cyclone. They do. Polar WX has ocean heat content. I hate that. But we're looking at the ocean heat content values is what I want. That's fine. I'm not even gonna. The point is when we're looking at this system, we have the strong moisture feed for days and days and days. I mean, from birth to death, this system is going to have a really strong moisture feed. You can take a look at this is our system. Too much, too much, too much, too much. This is our system down here. You can see it's working with some dry air to the north right now. It's being sheared some, so that's why we haven't seen development yet. I can show you the wind shear, current wind shear. This is now. You can see we have some wind shear that's working against the system, probably associated a little bit with Fiona. You can see the outflow of Fiona here, and then we also have wind shear working down this way, which is shearing the system from north to south at the moment, and even west. There's probably some northeast wind shear too. You can see here, so our system's moving this way, but it's being sheared from the north right now, so that's causing some problems in terms of intensification, for sure. That's why we haven't seen it intensify yet. No clear closed circulation, but sharp wave axis for sure, meaning that it's probably getting close to having some sort of closed circulation, but it's going to need a little bit of convection to fire up in order for that to happen. If I show you, obviously that's the beast Fiona, but if I show you, the frame, it gets a little bit laggy. I get that, but it's still decent. You'll be able to see it. You can see there's not a ton of convection firing up at this point. These are just thunderstorms down here. This is less tropical and more, sheer. Thunderstorms being produced just by more regular weather compared to this is what we're looking at. You can kind of see it being sheer in general right now, but this is our wave that we're looking at, tropical wave 98L, and we're going to look for this. It already has a good moisture feed. It obviously has a little bit more dry air to the north at this moment. We'll show you water vapor. Boom, boom. Nope. Yep. Weather Nerds great. I don't know if y'all use tropical tidbits or not, but I love Weather Nerds. I use tropical tidbits too. I like tropical tidbits a bit more for visible, but Weather Nerds, I'm sure most of you know about this. With my go-to. You can see the dry air to the north though. Right here, this is our dry air. And you can see there's no clear, you don't look at this and go, oh, there's the spin. We still don't have that tight Vort signature yet. We're going to look for, I'll show you 850 in a second. I'll show you low level Vort. But this is our dry air to the north. This will fade away. Even then, it's still got a pretty solid, all this is a lot of moisture for the system to enclose itself around. So it's not really being, pressed by dry air. It's not like dry air is really, really working against the system. It's going to need its Vort signature to come a little bit closer together. It's going to need that low level vorticity to tighten up. We're going to need a little bit tighter spin on that. And we're going to need a little bit more convection to fire up. And once we see that happen, that's probably when we see development. Actually, National Hurricane Center has 90% in terms of their odds over the next 5 days. Take a look. 70% over the next 48 hours and 90%. Those are pretty fair odds. I think we do see it form in the next 48 hours. I'd be a little surprised if we didn't. I could understand why. It could be a little bit sheer. So sheer could be putting some impact. But at the same time, we talked about this on all of our streams with these tropical systems that, you can have, go back to, you can have dry air, but there is shear relevant right now. You can have dry air, but if there isn't a ton of shear to transport dry air into the core of the system, imagine the center of our system's right here. If there's not a lot of shear to transport dry air into, then it's probably going to tilt the vortex some, but it's only going to tilt the vortex until shear is in a no longer favorable spot to affect the storm. So shear can only do so much until, potentially it even gets into a position where maybe shear's not going away, but you still have good outflow. The shear is positioned to give, with the center of the system, to give really good outflow to the system. But as we progress in time, shear is going to go down. And it's this combination. Obviously, we have some shear present right now, as I mentioned. Actually, I even want to zoom out a little bit. As we play this in time, play this through a few days out, you can see shear starting to be a little bit less of a problem now at this point. At this point, the outflow, it's like this. So it's still not perfect, but this shear is probably not affecting it all that much at this point. Probably a little bit of westerly shear at this point, so it's probably still vortex or low-level center or mid-level center is probably still a little bit tilted. We talk about this all the time. For those of you who've been in the streams this week, we talk about this low-level center or mid-level center. We need these to be stacked in order to get the best intensification we can of the system. I'm not rooting for it. I'm just saying that this is what needs to happen in order for tropical systems to strengthen at a more sustainable rate and start to take off. But if our low-level center is here and our mid-level center is displaced from the low-level center, this doesn't work. You can see we need this to be stacked, and if it's this displaced from the system, it's going to be harder to see more significant intensification. That's what we were talking about Fiona when it was tracking all the way through here, and then right before I hit Puerto Rico, that's when we started to see this thing. Its low-level center, its mid-level center come a lot closer together, nearly stack, not perfectly, because it was still a Category 1 hurricane. It wasn't a Cat 3, wasn't have Cat 3 winds. Like right now, it's pretty close to perfect in terms of its mid-level and low-level center. If I show you recon of Fiona right now, notice when they went through the center. We have our winds, flight level winds, and the surface pressure readings. And notice how these correlate exactly. The spike and drop, they correlate perfectly. Obviously not perfect, but pretty close. That is a stacked system. This is a low system that have its MLC and its LLC. It's low-level center, it's mid-level center stacked. And that is what leads storms to be primed to intensify. So once we see this system, this is currently 98L. So once we see this start to get its low-level center and its mid-level center stacked, that's when we can start to see this thing really take off in terms of intensification. And that probably still won't be for at least a few days, potentially. Unless bearing something crazy. Models can mess up forecasting the environments. They've done that time and time again, as I'm sure many of you know. But as we progress, shear is going to go down. If we look 4 days out, now we really start to see shear not be relevant. And when we have not a ton of shear to be able to transport dry air, and we don't have a ton of dry air in general, that is a formula to see an intense hurricane, plus 29, 30 degree sea surface temperatures with formidable deep ocean heat content. Play this out. Even then, we can start to see the dry air start to fade a little bit. This is what I'm looking at right here, this 1002 millibar storm that the GFS has ticked right now. It has close contour lines. That's the system we're looking at, and you can see it has its pretty sustainable moisture bubble right here. It's pulling in a lot of moisture probably from these. I don't want to say pulling, but the moisture feed off of South America, the thunderstorms, is probably helping indicate, probably not helping the shear. That's why, the storm this low in latitude is probably being sheared still a little bit, part of it. It's not able to take off. Once we see it raise a little bit in latitude and get away from the terrain, will be part of why we'll probably see this system be able to intensify a bit more. But one thing that the terrain isn't doing is it's drying up our system. And that's one thing that's probably being supported. It's not like help. I don't want to say helping it like significantly, but it's not taking away from it. And so it's allowing the moisture bubble to be pretty significant and at least fend off dry air. So dry air to the south is not a concern, really through majority of this system. And then dry air really starts to fade away. And if we get into the western Atlantic, we'll zoom in. It's a little far out. And then we get into the western Atlantic. I mean, look at this. This is, textbook. Maybe not textbook, but look at the moisture feed. This is beautiful, and even then, that doesn't even encapsulate everything I'm trying to show. I mean, it's even bigger than that in reality. I mean, look at all of this moisture, and even then, this is not deep browns. These are not deep, dark colored browns. These colors, that's dry air. See this kind of a front now at this point. Fiona's creating. This is wrapping in this dry air, this clash of dry air and cold air at this point. It's basically Fiona's combined with the extratropical system and created front at that point. Imagine the front, with a winter storm in the northeast that you see severe thunderstorms associated with that cold front that runs through the southeast usually. That's kind of the similar scenario here at this point, but a little bit more tropical characteristics with this, as we mentioned earlier. But again, it's this moisture bubble that we have here. No dry air in sight to be able to get into this system. And this is the center of the system. This part right here is the center of the system, and what's going to be the core, and that's what we look for to intensify. Even though we're not looking for dry air to get into this part of the system, we're looking for dry air to get into the core. And the fact that the closest dry air is over here and over here, and it's not even, this isn't the most significant point for strengthening we're looking at. This is what makes me think that, this is going to be one. I tweeted earlier, this is going to be one of them ones. This is what makes me think it's going to be one of them ones. And it's not the 940 millibar storm in the Gulf on the P-type map. It's not what interests me. It just happens. It just happened to demonstrating that this is going to be a really good environment for intensification. So this weekend is when I think we could see the system start to take off. You can see it starts to really, you can see these moisture, you can see the relative humidity, you can see the greens here, the greenish bluish, you can see these colors really start to deepen and darken and indicate that it's really firing off convection. There's deep moisture returns coming off the center of the system. Dry air is even fading, so the stronger the system gets, the more of a moisture bowl it's going to create too, and it's going to be less susceptible to taking in dry air. So as we play this out, we try not to go, we're not going to, I will probably look at this in terms of what happens, the final result, because I'm trying to see all these final results that happen in this model runs to see all the different scenarios and how they differ and why it changed, what led this to change, what happened to make this happen a certain way. So that way, when it comes time to really figure out all the different reasons, we could see a change in track. That way I understand, okay, well, we've seen this amount of model runs do this, which led to this. Our high pressure was higher up on this run. I'm just saying, for example, and that way our system, was able to get a little bit farther north. But let's say our high pressure was a little bit more west, the system, and it was able to head up a little bit higher east. That's the kind of things that I'm looking at with all these runs. So I'm not playing it out to see, oh boy, that's intense. We're looking at a 935 millibar hurricane. That's not why I play them out. I play out the model runs to figure out all the different scenarios, and then once we start to get closer and we can figure out the most likely scenario, at that point we can understand why the model is showing that. And that applies to winter storms too. That applies to winter storms as well. It's a little bit more general, and And with it being that general, it can make it a little bit more susceptible to change with the upper level patterns. And that's why the upper level patterns become a lot, not, I mean, they're equally important as in terms of impacts to the person, but a little bit more important in terms of track of the storm and how the system lifts itself with the upper air pattern for winter storms. You can see here at this point, we have a hurricane at this point on Sunday, and again, it's this ridiculous moisture bubble. It's not like a stork or something, but it's really beneficial. There's no dry air to be found. Maybe more like this. There's just no dry air to be found. We're not looking at dry air trying to penetrate the system. And that's why, as long as wind shear is not super strong and tilting the vortex, that's why this thing is going to take off. And honestly, it wouldn't shock me if this thing gets stronger faster. It's possibly underdoing the rapid intensification. Not maybe the timing of when this happens, because maybe it takes a little bit longer, but once it does, it's going to take off. It's going to take off. It's probably going to take off. Again, this is, it's 5 days out. Changes will happen. So maybe the environments that models are agreeing on right now, it's not just the GFS. I'm just showing, it's just, the models are in pretty decent agreement right now. So I can show one model and it be somewhat similar to the other one, which is finally something either could be good or it could be bad, I guess, at one point. But it's makes it a little bit easier to talk about this system and not say, well, so many different possible scenarios. No, we're pretty confident that a hurricane is probably going to form at some point later this weekend in the Caribbean. I can probably say that with a good amount of confidence. I would be pretty shocked. I'd be pretty shocked if we didn't see a hurricane form at some point this weekend. And obviously, look at the intensification. GFS kind of picks up on it here. Look at this thing. From hour 108, 8 a.m. on Sunday, we go from a 990 to a 953 in 24 hours. That's 37 millibar drop. 37 millibars in 24 hours. That's a ridiculous drop in pressure. That's a ridiculous drop. And that's the kind of environment that we're looking at. And look at, this moisture. I can't get over it. It's going to be really hard to transport dry air into this system. Really hard, especially in the Caribbean. And look at the wind shear. Oof. Look at the outflow. It's upper level high pressure that's going to be sitting over this system, this upper level high. And look at the outflow. That is it doesn't get much better than that. It's not like the most perfect you'll ever see, but when it's this good, that's good enough. That's plenty good enough. That's plenty good enough. It's like looking at something. Obviously, a 26 degree sea surface temperature, yeah, that can form a hurricane, so that will get the job done. But we got 30 degree sea surface temperatures, yeah. That's 30 is not the highest on record, but yeah, that's gonna, you could see a major hurricane. That can support major hurricane, and that's kind of the same message. When I see this, when I see the wind shear, 200 millibar winds here, and I see the way that this high pressure, this upper level high, the way it's going to be steered for the system. And when I say steered, I mean, the way it's going to help the system intensify down the road. Again, I still have to say this with if the agreed upon solution models are showing relatively agreeing, if this comes together. There's still a lot that can change. There's no doubt. I show you this, play this out. It's a little bit farther than I like to go. 132 hours, so it's not super far, but it's typically that 5 day range is where as far as you want to go. That's why the National Hurricane Center really goes out 5 days with their cone. But I mean, man, I'll play this out a little bit more, just so you can see. I mean, and the outflow is going to be really good. We have jet stream back here. Not the color I wanted. And not the size, more importantly. Size matters. I'm just kidding. It's a joke. The size of the pen does matter right here. I promise you that. So you can see it. There's the jet stream. And that's our system. Oh boy, that's strong. Bookmark it. Cat 5. I'm just playing, y'all. Just playing. I promise. I know I say it monotone and with a dry sense of humor. It can be hard to pick up on, but I promise I'm just joking. It's and eventually, with this system building up as strong, it's still a pretty relatively small system at this point. And at that point, it's not going to be too deterred, probably. It's the environment's still going to be really bearing some. Again, this is a little bit far, so this is why I hate going this far and trying to tell you what the environment is going to be this far out. But based on what models are saying right now is that if the storm is able to intensify this much at this point, probably look for an eye wall replacement cycle at some point. Once we've seen a storm this strong, we'll see a stronger eye form or even a landfall. Who knows? And then we start to see the system a little bit potentially be able to fend off dry air, because eventually at some point the system is going to have to run into dry air. I hate getting into specific details as far out, but you can see at some point it's going to have to work against this big bad dry air. At some point. I mean, is this connected to Fiona? Is that boundary created? It's connected to Fiona. Hold up. I know some part of the system is going to be connected to Fiona. But let me take a look here. Let's see. Yeah. Kind of. A little bit. I mean, you can see Fiona. It's a new trough. So a little bit. Fiona's. This is Fiona. This is probably still some leftover Fiona. This a weakening boundary at this point, and then this new system. This would be a miss in the wintertime. It would be a late phaser. Wouldn't get its act together until Atlantic Canada and far north Atlantic Canada. Excuse me. But yeah, this will be connected. So we have our boundary right here. High pressure, dry air. Right here. Front. In this system. This will be important to watch, this system right here. We talked about following the troughs in terms of the and looking for the weakness in the ridge and the timing of the depth in the trough, which is still important. We're still trying to figure that stuff out to this point because that will impact the track. But we'll probably have to watch this one. That will be the trough to watch. This one right here. This will probably have a big impact in terms of East Coast impacts. If this were to, again, I'm going to such specific details so far out, but even this is still relative because this is going to affect the steering. And I mean, all you want to know is the U.S. impacts. It's like 99% U.S. people that follow me. Maybe not 90, but they're like 95. So this is why however many of you are in here, the 6 of you or whatever that are in here, you're curious about the U.S. impacts right now. And that's what you want to know. So I'm trying to go and list the different scenarios what we look at, and depending on this system right here, that's gonna define where our weakness in the ridge is. This is our big ridge right here. Ridge right here is where it's high. Or in our high pressure of the U.S. This is the steering, what's going to lead to this system. And this system's probably going to try to work its way through here. And I remember, some of you may remember, I don't know how many of you are in here from streams earlier this week, but we talked about storms that are strong enough can just push their way through a ridge. Storms that are really strong enough. So if this is going to be one of them ones, like we were talking about, this is going to be one of them ones. It's going to be able to steer itself a little bit. It's probably going to try to push its way through that ridge. Probably slows down a little bit and then tries to push its way through its ridge. So again, we're still far out. I mean, this is, hell, 6 days out. 6.5 days out. But this is still all relative. Still all relative, because the storm is there's going to probably be some U.S. impacts with this system if it is what we think it's going to become. If we think it's what it's going to become. How specific, we don't know yet. But we'll be able to nail that down once we see the system form. We get a little bit closer to the specifics of the upper level environment. 500 millibars will be key again. We'll track 500. 500 is my specialty. 500 Vort especially. Obviously for my winter followers, you know that. But I think this is going to be one of them ones. That's what I think. That's what I think this is going to be. We can't, it's too early to tell landfall, and land impacts yet. So can't say, how historic, whatever, because you don't know, it could try to make a landfall and then dies out or something. I don't know. That was about as least scientific as I could get, but I think this one is this is the one of this. You have that one storm this season. That one storm last year was Ida. That was that one. Obviously there were others. There were others that were really strong. Because it was a big season with other U.S. impacts, but that one is Ida. You have that one. Every somewhat active season, with enough storms, you had that one storm that you track for like 10 days, and then eventually it makes that devastating landfall somewhere. This is going to be. I think this is. I'm not just going to say devastating landfall. I'm not trying to be like direct weather here, but this could be one of them. I keep saying it, one of them once. I think this is the one, potentially the banger of the season. And again, if you guys, I know I've been just putting out. I think I've been putting out some decent content here, so I can understand, maybe why. I've been throwing a lot of information out, a lot of good information, but I can understand why you guys probably haven't been asking a lot of questions, because I've been going over like everything, like every little aspect to an extent, to what I know, and trying to simplify it for you, and try to hopefully help you understand what I'm looking at and what other people are going to be looking at over the next few days or so, and over the course of the week, the rest of the week with this system, and why it has people's attention, why people keep posting those 8-day model runs. This is the one of the season. We can play this out. See, I don't know what it does, but yeah, oof. Hello there. Let's go even farther. Let's go to 384. What we got going on at 3? We can't even go there. Another tropical wave. Bookmark it. October 3rd. Tropical wave. New tropical depression to track. No, I'm just kidding. But I might have been sorry if the voice wasn't too strong. I might have my hand over my mouth a little bit. Um, but in all seriousness, this could be start to become an active period. This really could start to become an active period in the Atlantic, where it's just wave after wave after wave coming off the Atlantic, off the African coast, and each one something to watch. We could be transitioning to that point in the season. We could be transitioning to that point in the season where it's just wave after wave after wave. And then we keep tracking through mid-October. Who knows? But Ace is about to go up. I'll show you guys what Ace is. ACE is accumulated cyclonic energy. That's the acronym. And it's a number that can be used to track how, it's a good way to track how strong systems have been and how long systems have been alive for. So it's that combination of how long systems have been alive for and how strong the system is or was at some point, and how strong it was for a duration of time. I've been talking a lot. I think it's my longest stream yet. But you can see the rise. This was Earl. Went from 2.8 all the way up to 29.6. How long was Earl alive for? Earl put 14.2. It was a combination of Danielle and Earl. So Danielle wasn't super strong, only 80 knots. But you can see it added 12.5. And there's a equation to do all this stuff, but went from 2.8, and then Earl and Danielle kind of happened simultaneously, a couple of days apart. We saw the Ace rise to almost 30, and then Fiona formed, slowly going up, and then it became a hurricane, and then Ace started to take off again. So we're over 40 with Ace. My guess is after Fiona and after this next system, probably gonna go over 80 is my guess. Maybe even 90. And we'll get to average, close to average. So we're about 25 points behind average at this point. 25 points. And we'll probably get a little bit closer to it. But yeah, if I don't even know if there's anyone in the chat right now, but if there is, if you have a question, feel free to ask. Otherwise, I'm about to hang out my cleats here. About to end it. But if you do have a question, feel free to ask. I was just going over the Ace here. Actually, we'll take a look. We'll take one last look at him. I don't even know if I have anything to tweet on 98L because it's been the same crap as last night. The stuff I tweeted is still applicable to tonight. All right, finally getting to the system. Beginning of the stream, I talked about it. It's been about an hour since then, and now it's starting to get back into the center. Into the core. I'm curious. I'm really curious with this flight. I thought it was going to be Cat 4. I looked at that satellite last time, and now. Let's see. Let's take a look at satellite. Seems like it's fended off dry air pretty well. There's some intrusions. Looks like it's fending it off pretty well. It's had that band of thunderstorms around the center for a while now. Yeah, I knew that was going to happen. Why did I know that was going to happen? It's had this band of thunderstorms rotating around. Luckily, there's no land here. Otherwise, that'd be a big flooding situation too. But it's had these convective bursts, CV bursts. If you saw me tweeted the acronym, rotating around consistently. It's been firing these up, and some dry air has been trying to work in. Looks like the eye's getting a little bit cloudy, a little bit. But yeah, I think the 2 a.m. advisory, I think that's when we see the upgrade. With this recon pass going through, if we don't see, I'm not expecting recon to find like a big pressure drop. Even it could rise honestly, but I think the winds are now going to catch up. I think the winds are going to catch up to the pressure drops we were seeing. Like we saw like a 10 millibar pressure drop over like a I think a 3-4 hour period today, earlier this evening. So I think that pressure drop is going to translate to the winds going up. That's my guess. Because I mean, satellite it's beautiful, deadly. It's deadly, but it's beautiful right now. You know this satellite easily supportive of it being a Cat 4 right now. I'm sure Dvorak, and rest in peace, Mr. Dvorak passed away today at the age of 100. Saw it on Twitter. Someone posted about it. The Dvorak satellite stuff is important. It's used by the National Hurricane Center. They have to use it with a grain of salt, but rest in peace, Mr. Dvorak. Big advancements with meteorology and tropical forecasting. The Dvorak satellite system, really important. So, condolences to his family. Let's see, recon any closer? Oh, we should get an update in a minute. They're getting really close to that center. I'm curious. So they're probably not going to get the strongest. So if that were to be my guess, typically look for the northeast side. It could be up here. This is the eye. But I think the winds are going to catch up. It already looks promising, the wind field. Expanded today after that eye wall replacement cycle. We get that update. Yeah, there we go. I could use the loop. I don't mind seeing the loop. It's like there's a little bit of cooling in cloud tops in the eye. This little part right here, right in the center there. I mean, it still looks really healthy. Maybe a little bit of shear, a little bit of westerly shear you can see here on satellite. I swear I don't have COVID. I've just been talking for about an hour and a half now. A little bit of shear. And sometimes it's not necessarily killing the storm too. When you with shear on this side, potentially it could be helping outflow. It doesn't look like at the moment, but because there is a little bit of dry air trying to get into the system. If we look at satellite here, we're already on satellite. But if we do look at water vapor, yeah, very visible. So it's got a pretty strong core. So it's going to be able to hold this off a little bit. You can actually even see, the dry air into the eye right in here, which means the eye is warm. It's warming. You look for the spike in the eye, and then you look for the dew point to go down in a very healthy eye of a strong storm. But you can see the dry air off to our west here. Definitely a little bit of shear too. See, trying to work into the system, probably into here. You can see it right here. Trying to work into the core of the system, but that eye wall replacement cycle helped to. I was pre-eye wall replacement cycle, be struggling a lot more. a lot more would be struggling. But with the eye wall replacement cycle that happened, making the size of the eye a bit larger. Now at this point, we've seen that this has helped the storm to fend off dry air and shear intrusions. I hope that recon. I guess I can stay. I can stay. I gotta get up early. I gotta get up early tomorrow. So we got any closer? Yeah, I mean, can we get the update? Come on, Tidbits. What are we doing here? No. All right. I guess on Twitter post it. Don't even get. Okay, I don't mind that. Man, those bot notifications. Oof. Oof. Maybe an update. All right. Well, I guess we'll call it a stream. Thank you for all for tuning in. I think this was our biggest stream yet. That this time, or not the biggest stream in general, but this coverage so far of this storm with Fiona. And I think it's only with this 98L. I think we're gonna get streams popping this weekend. I'm not sure if I'm gonna be able to do streams tomorrow and the next. If I have time to, I will. I actually might be able to do it Thursday night, I think, or tomorrow night. I forget what night. What night I don't have plans, but I am going out of town, so I'm not going to be able to do streams Wednesday night and Thursday night. Most likely, one of those 2 nights I'm not going to be able to. And then Friday night we'll get back into streams, and then we track. There's probably going to be a long 10 days of tracking, probably. That's my guess. A long 10 days of tracking. So yeah, I'll see you guys later at some point. Over the next 2-3 days, I'll be back on. I will not stream one of the next couple nights. I won't stream, but after that, we'll get back, get these nightly streams popping again. This weekend, I bet, it won't be a school night. That doesn't really impact me, but won't be a school night. Probably get some of a lot of the high schoolers in here as well, or I guess college kids too. College, you got those early classes. Get some of them more people popping in here because U.S. impacts. People are going to come in more. But yeah, that's going to do it for me. Hope you all have a good night and good week. Yeah, good rest of your week.